So the last thing we did in this lesson, and remember, just to sort of recap this lesson, we talked about how to problem solve using exponential equations by logging both sides and solving from there. Then we talked about a certain number, and all we talked about is how we got that number, how you get it. Don't worry about that, okay? But I did want to show you where it comes from. Just remember the number is about 2.7, okay? And it's just a constant, just like pi. It just happens to never repeat or never end. Now, it's a special number because we can use it when solving exponential growth or decay problems, which we'll do in a second. Okay, but this e, just like if it was y equals 2 to the x, y equals 1 over 3 to the x, y equals 4 to the x, we can graph it. We just use 2.7 as the base, and we get an approximate graph of it. Okay, it also has an inverse function, which means if we've got y equals e to the x, make sure I get this right, its inverse would be y equals log base e to the x. Just like the inverse of y equals 2 to the x is y equals log base 2 to the x, or 2 of x. Okay. But we give it a special name when the base is e. We call it the natural logarithm, because we can talk about natural growth and natural decay with this number. And instead of log e, we write this. Y equals ln x. And usually the way we pronounce this, ln. Think of a ln, ln. That's an ln. So a ln is just a special type of logarithm. Just like when there's no base, that's a special type. It's base 10. We call it a common logarithm. Okay. And again, we can graph these things. We can graph this. We can solve equations with it. Okay. We can use the log laws with it. Like we can do all the same stuff. Like if you graphed do you remember what the graph of a log looks like? How it curves? Hopefully you remember its curve. Do you remember how it curves? Do you remember where the asymptote is? Okay, I'm seeing some drawing. I'm seeing people going like this. This is a positive start. Really? We don't remember how to graph a log? You're going to have to. It's the, well, no, it's the inverse of exponential. Remember, exponential goes like this. Okay, this is exponential. This is logarithmic. And most of them look like this. It depends on what the base is. Okay, but they're all pretty close to that. So log e of x or ln x would look something like that. How would we find it? We would go if x is -1, we find the log of -1, or sorry, the ln of -1. If x is 0, we find the ln of 0. Or sorry, if x is 1, we find the ln of 1, which is 0. And then if x is 2, we find the ln of 2, which is the log base e of x. And actually, you have a function on your graphing calculator. It should be below your log button. Okay, there's an ln button. Yeah, any scientific calculator. If you see ln, that's what we're going to use this time. Okay, but like I said, we can do, I mean, you can do log laws with these, because remember, log is just a type of log. So if I said, still in a little review here. How could I write this as a single log? Now the next one. On 3x minus 3y, or sorry, 3x divided 3y, pardon me. Right? And then the final one. How could I write that? 4 ln x. Okay, so that's what it means by using the log law. And we can sketch the graphs. So it'll be the red one. Just don't get thrown by the fact that it just says the letter E. Okay, how do we use it? Let's look at a couple of examples. So there's a standard formula that we use for continuous growth or for continuous decay. And this is the standard formula, where A is the amount of whatever, money or substance or whatever, after a certain period of time. P is how much you start with, the amount of something you start with. R is the rate that it grows or decays, okay? And T is how long it's the time that it decays or grows for. E is just 2.7. Okay, so we've got a population of 500 bacteria that grows at a continuous rate of 5%. Using the formula A equals PE to the RT, where you're told everything, you have to answer 2 questions. What will be the population after 20 hours? So again, you may want to do this, you don't have to. It's the amount I don't know. What's the population I start with? 500. What's the rate? 0.05 as a decimal. And what's the time in this question? 20 hours. Okay. So the first one's pretty straightforward. I just plug it in. 500 times E to the 20 times 0.5, which is the same as 500 times E to the 10th. Oh, 0.05, sorry, thank you. I knew that seemed wrong. Which gives us 1, not 10. Well, what's E to the first? E. So you have to do E times 500 on your calculator. Where do you find E? Should be able, if you're on the graphing calculator, it's above the division symbol. So I could go second E, raise it, or sorry, 500 times E. 500 times second division sign should give me, let's go to the nearest hour, 1,359. Okay. You should be able to find it on your scientific calculator. If you can't, let me know. I'll help out. What's that? 1,359 hours, approximately. Next question asks for time. Okay. So this one, A, B, R, T. Which one's the unknown this time? T. It says how long to the nearest hour. So I must know A, P, and R. Well, R is still 0.05. P is still, is it 800? 500, pardon me.
Isn't it 1,000?
So yes, what would A be? It would have to be 1,000, right? Because we're trying to find how long it takes to double. How long does it take to go from 500 to double that? Okay. Double E. So now when we set it up, we're going to get an exponential equation. So 1,000 equals 500 to the R, sorry, to the 0.05 times R. Okay. Jeez. Littered with mistakes today. I forgot the E. Yeah. Okay. I need to bring T down from the exponent. But is there something I can do first? What's that? Divide by 500. Get rid of what's in front first. Divide by 500, divide by 500. I get 2 is equal to the 0.05 T. Okay. Now, sorry, log or ln both sides? Why do we ln both sides? Because we're dealing with the base of E. What's that? Because we have to put them in log form in order to use a log law to bring this down. Because we want to bring it down, right? Oh, because it's base E. If there's an E in there, you're using ln. So ln 2 equals, well, now I can use my power log law to bring the exponent in front, which is what I wanted to do. So be careful how you read this. 0.05 times T times ln E. Well, actually, this is really easy. Because isn't ln the same as log base E?
Yeah.
So log base E of E is E to the what is E? Anything to the what is itself? 1. 1. 2 to the what is 2? 1. Smiley face to the what is smiley face? 1. E to the what is 1. E. 1. E to the what is E. 1. Well, no, I'm just saying that this is the same as this. So whenever you have ln E, just remember ln E is always equal to 1. So really we can cancel it out because 0.5 times t times 1 is just 0.5, 0.05 t. Wow, this is so brutal. Well, yeah, because times 1 just keeps this. Anything times 1 is itself. So how do I solve for t now? There's one thing I have to do. Divide by 0.05 on this side, divide by 0.05 on this side, and t is going to be approximately, it says nearest hour. So remember, use the ln button. Ln 2 divides 0.05. Nearest hour? 14 hours. 14 hours is right. Yeah, it's around the log button is around the log. Okay, no mistakes on this one. Slow down, Kev. Slow down. Slow down, buddy. Not too fast, buddy. A radioactive substance is the gain according to this formula. Well, that kind of makes sense because a negative exponent represents decay. A is the amount of substance remaining after t years. P is the original amount of the substance. T is the time in years. If there are originally 80 grams of the substance, how much is left after 3 years? So again, A, P, R were actually given, so I don't have to worry about it. T. What's the unknown? A. Which means P must be 80 and T must be 3. So this is going to be like a straight calculation. A equals 80 times E to the negative 0.2 times 3. Or A equals 80 E to the negative 0.6. So this is where on your graphing calculator, you got to find E or E to the X. Okay. Then you got to raise it to the negative 0.6 and get an answer. Once you get that answer, you have to times it by 80. Okay, let me try. E to the negative 0.6 times 80. Yeah, 44, that's what I got. 44 grams. Okay. Perhaps you dealt with this in chemistry, half-life. Okay, don't be triggered. Half-life is how long it takes for a substance to get to half of its original amount. What's the unknown? What's the half-life? I'm trying to find how long, T. P is 80, which means A must be 40. Because it's half of 80. So using the formula, 40 equals 80 times E to the negative 0.2 times T. I can get rid of the 80. What does the left-hand side work out to? Half is 0.5. Now I have to begin the process of bringing this exponent down. And it takes me a couple of things to do. Log first. And now I can use the power log law to bring this exponent in front of log E. So I get negative 0.2 T times log E. That equals 1, which means it can go. No, and not in this type. Yeah. That's a nice thing about using it. Divide negative 0.2. Divide negative 0.2, and we're going to get our time. No, it doesn't give us a S. Doesn't ask us to round it to a certain amount. Let's go nearest. 3.5. Okay, let's leave it at 3.5. Perhaps you need parentheses. Thanks, that was sweet. Whoop. Can't really understand. You get the title of that.
Oh, yeah. Hockey. I don't.